There we go. And it's recorded.
I just need it an hour or less to plug in, okay? My computer's dead. You can unplug it.
So welcome all. As usual, I do not have an agenda or a plan for this. This is just let's get together and talk mods. If somebody wants to show off something they've been doing, great. If it ends up just being people asking me questions, that's fine too. And when I get done with this, I'm going to go crash. I'm tired. Been working on a K install all day, and had some difficulties, but overcame them.
What K was it?
It's a 20.
A 20?
And I'm installing 4 lithium batteries, 4 Battleborns, 2 below, 2 above, and the Victron 3000. So basically the same install I do on either a G or a K.
I see.
Much. 4 batteries, inverter, the inverter control panel on the wall, auto generator start hiding behind the one place that's tied into the BMV 712. So you set on the BMV 712, you set it like start at 20, stop at 80% charge, the generator, so that if your batteries do run down, it'll automatically kick the generator and charge them up again.
Nice. I have a question.
Yeah.
When you're charging lithium batteries and they're taking the charge source from the engine because you're driving the road,
right?
What's to, what charge profile are they getting? Maybe that's a stupid question, but I just don't understand that.
They're sort of getting an AGM charge profile because that's what the alternator puts out. But the alternator actually just puts out 14.2 most of the time.
Okay.
If the voltage gets up high enough, long enough, it may drop the charge voltage level. But in terms of, if your batteries are low and you're driving, it's definitely going to charge them, and it's going to charge them as fast as it can. Right. Now, one of the catch-22s is that the alternator only putting out 14.2, and the fact that lithium batteries, once they get above being mostly dead, in other words, if they're down like 10% charge, their internal voltage is pretty low, and they will take a huge amount of power from the alternator and charge up pretty fast. So pretty quickly, even if you started out pretty dead, they charge up enough that they're back up to their usual 13-ish something volts instead of under 12 that they like to maintain. At which point, the smaller difference as they get charged up off of the lowest level, that smaller difference in voltage means that the current comes way down. So the one drawback to alternator charging using just the conventional alternator that's already present in the RAM ProMaster is that it will charge fairly quickly at first and then slow down. You'll get up to 90% at a pretty decent charge rate. You'll see over 100 amps initially, and it'll drop down to like 60 pretty quickly, and it'll be 60 to 40 for most of the bulk charge. We're talking about 4 batteries here. And then as it gets closer to 90% charge, that's going to drop off, and it drops off normally anyway, even with a regular 14.4, 14.6 charger that is supposed to charge lithium batteries. But even with the 14.2 on the alternator, it still charges, but it slows down a little faster as it reaches the top. With lithium batteries, even with a normal charger, you're going to get to 90-95% pretty quickly. But then that last 5% of charge takes, it seems, forever. So, you know, if you weren't, if you were only 50% down, say, on your 400 amp hours worth of battery, so you had 200 amp hours of charge available, and you're running the Victron 3000 as your charger off some shore power generator or whatever, you know, in 2 hours, you're going to be able to have put 240 amp hours into the batteries. You should be able, in theory, to get them all the way up to 100. But the fact of the matter is, once they reach that like 95%-ish charge level, the current comes down really fast. And so the last 5% of the battery charge takes way longer than you think it should, because the batteries are mostly charged up and they take the last bit getting to 100% very slowly. Really slow down. I mean, you see it at 10 amps, and then it's at 7 amps, and then it's at 3 amps, and then it's at 2 amps for like forever, and then it's toggling up and down between 1 and 0, and it finally goes to 0, you know, half an hour later. It's really that last bit of charge at the end of the battery charging cycle really takes a long time because of that curve of the voltage going up and the current coming down. And the same is true with the alternator. It's just a little bit more so in terms of how fast it slows down. And the fact that it doesn't charge as fast as the Victron 3000, for example, because it starts out at only a 14.2. Really, I think it's trying to do 14.4, but what I see measured both at the alternator under some load and also at the batteries, I generally don't see it go above 14.2. But that's enough to get the batteries charged. So it does charge them, but it will take a long time. And a lot of people are surprised, honestly, after I put one of these systems in for them, how long it takes to finish topping off the batteries to 100% just using the chassis alternator.
Okay.
So you don't worry about getting, you know, the last 10% of your battery charge unless you're plugged into shore power, and then it happens pretty reliably. But you will get charged up, and it will actually reach 100% eventually. I've driven enough long runs, and also times when I wasn't all that far down. You know, I was only 5 or 10% down anyway, and I had several hours to drive. And by the time I got where I was going, it was fully charged. Of course, I also have solar on the roof, so sometimes I can't tell the difference between what came from the solar and what came from the alternator.
Oh, okay. I didn't think of that.
Yeah. And the solar puts out, it's my solar anyway, is the Victron MPPT, and it puts out, because I've told it to, a slightly higher voltage than both the alternator and also the Victron charger. So if excuse me, if I have solar power, that will go into the batteries first.
Okay.
But now, that's the way I have my system set up.
Yeah, I have 400 watts on the roof, and I still have the PWM
ZAMP.
ZAMP,
yeah, which works great. That's fine. That works fine. It's not as efficient as a Victron MPPT, but the little bit of difference in power that you would get out of switching to MPPT is not necessarily worth the cost and the hassle of getting it installed.
Can you speak to the wire gauge of coming off the solar panels in terms of, you know, what's the recommended wire gauge? Is it 10?
Anytime you're doing solar panel wiring, I would recommend do 10. You could go down to 6 for a run of multiple panels once you've combined them, bringing that to the charge controller.
With 12 volt you're talking about now, right?
Sorry?
With 12 volt panels, right?
Well, 12 volt versus 24 volt, you're still talking about some power loss, but at 24 volts, it's not as much.
Right.
I'm running a 24 volt system, for example. I am running actually just a pair of 10 gauge cables down from the roof from all of my 600 some watts of power solar on the roof.
Yeah.
into the Victron MPPT, and that works fine.
But just what's on the roof there, coming off the panels to the plug-in at the back. I've got a K.
Yeah.
Those wires should be 10, getting along the roof line.
And they're usually not, and I would recommend upgrading them to 10 if you don't mind going through the bother and expense. You'll get a little bit of it's not a horrible expense, but it is a bit of a bother.
They aren't cheap.
Redoing the wires, and that will get you some extra power a little bit, just because there's power loss depending upon the gauge of the cable.
And the best place to measure that would be unplug it and check it right at the panel, the voltage output, after it's gone through the wire, right?
Well, you can't really tell just looking at what's coming out of the solar, because of course that's dependent upon the sun. To tell what your loss is over a cable, you'd have to put a meter across the input and output ends of the cable. So you'd have to have like a big long coil of cable and have it plugged into the solar panel here and plugged into the ZAMP on the other end, and measure the voltage difference across the length of cable. And then you can calculate how much resistance that cable is.
I see. Okay.
And how much power you're losing over the cable. But yeah, as a general rule, if you can run 10 gauge from solar panels, do.
Okay. Just one last question.
Yeah.
If your battery runs low when trying to start the Travato, and you use the switch to give it a boost from the
chassis battery low, yeah.
They are lithium. Is there any harm that can be done to them from using them to help you start by pushing the button on the dash?
No, not at all. What you want to do though is hold the switch in for a little while, like 30 seconds or so. Give the lithium batteries a chance to jumpstart. It's the same way you would do when jumping a dead battery. You're giving the donor batteries a chance to put some charge into the starter battery and then turn the key. And you can keep the button in while you're turning the key. That's also not a problem. The cables going from the chassis battery back to the black box through the isolation solenoid and then connecting to the actual batteries, they are all 1 gauge.
Yeah.
So they're pretty hefty. They will have some loss because of the length of the cable, especially on a G, but not so much that they're going to heat up to a point of being a problem just from starting the engine. And the amount of power that they are going to dump through those cables, even with them heating up a smidge doing it, is enough to help boost, jumpstart the engine and get you going. So that's never a problem. In fact, closing that same isolation switch is how the reverse happens, that the alternator charges the batteries, whether it's lithium or regular AGMs.
Right. That would be jamming the switch, right? Is what you're referring to.
Well, when you're running the chassis engine, the run signal is sent down to the solenoid to close it.
Okay. Oh, okay.
So it not on an ignition, but once you've got the engine running, then there's two signals that come in off the B pillar, and one is the ignition signal, and the other one's the engine run signal. And it takes both before it closes the solenoid to cross connect and charge. So the alternator is spinning by the time the solenoid closes and allows it to then charge the house batteries as well. So anytime you're running the engine, that solenoid should be.
Seem to be breaking up a little.
Oh, yeah.
Okay.
Lovely AT&T.
You were breaking up a little bit.
Yeah. Gotcha.
Okay, I should be back now. Yeah.
Yep.
Yeah.
So anytime you're anytime you've got the engine actually running, that closes the solenoid, assuming the solenoid's working, and allows the power from the alternator to charge both batteries. Actually, what happens and what causes the solenoids to go bad is that as soon as the engine's running, it goes ahead and closes that solenoid, and the chassis battery, which had enough power, presumably to have just started the engine, the chassis battery dumps a huge amount of power through that solenoid right at the first into the house AGM batteries or lithiums. And what happens is that when it first closes like that, the contacts spark pretty significantly because of all the juice suddenly going through from the chassis battery to the house battery. Once that they level off a little bit and the alternator's charging all the batteries, all three in a house AGM, it's charging them all up together. But that initial jolt when the solenoid closes, that's what creates a huge spark inside the can. You don't see it. And that repeatedly sparking when you're starting the engine with dead house batteries is what builds up carbon on the contacts and eventually causes it to fail.
I gotcha.
That's why you get, a couple, 3 years, probably usually most, out of a starter solenoid, isolation solenoid, same thing.
I saw your video on how to change that.
Yeah.
I think. Okay.
And so that's why anytime I'm putting in the lithium system, I'm also putting in an LIBIM, which is an alternate version of a isolation solenoid that has wiping contacts. It has a motorized switch. It's kind of like those rotary on-off battery connects where it rotates. And that means that the connection's being wiped. So every time that it rotates, it cleans off the copper again and makes a good connection. So that kind of switch shouldn't build up carbon enough to fail in the same way that the isolation solenoid does, at least not as fast. It also, the LIBIM has a duty cycling mechanism where when the engine run signal comes to the LIBIM, it closes and opens up on a cycle of like 15 minutes, 20 minutes. And the reason for that is to allow the alternator to cool off a bit, because if you're charging a bank of lithium batteries, if you get just 2 or 3 batteries, it's no problem. You don't need to do this. But 4 or more, according to Battleborn, I really think you could still get away with it with 4, but it's a good idea to go ahead and replace the isolation solenoid anyway. But with so many batteries, the draw on the alternator starts to top off what the maximum the alternator can put out is. And then you start running into danger of overheating the alternator. And if the alternator overheats, it could melt down and you have to replace it. So the LIBIM is designed to prevent that by giving it some off time to cool off.
I see.
Oh. So Scott, I'm not very savvy. My name's Lori.
Hi, Lori.
I'm not very savvy about this battery stuff, but I think my batteries got damaged the first year I had it in storage. I got it in October, had to put it in storage. It was covered, and then snow was on the solar panels. And so it didn't get much sun, and I didn't have access to it to run it. And so I think they got run down.
If the voltage was really low, if it was below 12 volts, then
and it was cold. Yeah.
Cold is hard on the batteries, but it's being drained more than 50% is what really allows the battery to degrade.
Yeah.
You lose the lifetime. A set of AGM batteries should last you 5 years if you're using them gingerly.
Yeah.
Keeping them above 12 volts at all times. But yeah, enough times below 12 volts and you're taking months of life off of the battery every time it goes low. And eventually that adds up to the point where you just can't keep a charge. And
I'm not comfortable with what they're doing. I go to bed at night and it's maybe 12:05 and I get up in the morning. And one morning it was 11:09 and I had nothing on except the refrigerator.
Oh, okay.
And
that seems like too short of a time for it to run down that far. So you're not in dire straits yet, but you're at the point where you're starting to worry about it, which is correct. And
Yeah.
you probably only got a year life left in the batteries at this point.
So I'm looking at lithium.
Okay.
And I'm thinking I want to put in 3 Battleborns. Is that possible?
It certainly is possible, but I'll tell you what the 2 levels of easiness of doing this is. The first level is simply, and this is assuming you're on a 16 or later, because of course a 14 or 15 only
19.
has a single battery.
19.
But assuming you have the 2 AGMs, the absolute easiest thing to do in the world ever. In fact, I just put a video up showing how exactly to do this step by step.
I watched that. Yeah.
On the Travada Mods group. The absolute easiest way to do this is simply to pull out the AGMs and put in a pair of Battleborns. And it could be some other battery. You could do the carbon foams. You could do, which are half the price of the Battleborns. Mm-hmm. You could do some other type of lithium technology that's similarly sealed and suitable for being outdoor and weather. But the Battleborn has got a good price. There's a discount system. If you mention my name, it's in the documentation on the website.
Okay.
And putting 2 of those in, just yank the AGMs and put the Battleborns in the same places with the same cables on the same spots on the 2 batteries is relatively easy to do. And you don't have to make any other changes. There are some other improvements that you can do. I've got a plug that goes in the converter, for example, to change it to a lithium always charging mode so that it charges up a little bit faster. It's not a you got to do. It's just a it's a cheap little easy to plug in thing that gives you a little bit faster charge and gets them up to 100% a little faster, because you're not fighting with the converter dropping the voltage down as it needs to for AGM, but doesn't for lithium. So that's the absolute easiest way to do it. It doesn't require you to add any cables, doesn't require you to find a new place to put another battery. And if you get the heated model, you also don't lose the ability to operate in frozen weather. If you got snow on the ground, you can still pull the power out of the batteries, but you can't get them charged up again, because the internal computer in the battery itself and the Battleborn will say, hey, below 27 degrees Fahrenheit, I'm not going to accept a charge voltage. I'm not going to charge, which means that they'll go down and they'll go down and then they'll go dead. And then at that point, the only thing you can do is run the chassis engine to get 12-volt power again until you can get to a point where they're warm enough. So the heated mode from Battleborn is actually a really good option. It's a little more expensive, and you have to run an extra wire. So you do the regular, positive and minus cables on both batteries, the same as was on the AGM. But then there's an extra third little screw terminal on top of the battery. And you got 2 options. One is you just permanently put it on, and they have a little jumper that you just slip a connection underneath the positive connection on the battery and hook it up to that screw terminal, and that keeps the battery and heat mode enable turned on. It tells the battery computer inside the BMS to go ahead and allow yourself to heat up anytime you need it. That's just a permanent on mode. What I do when I put in Battleborns underneath that are heated model is I run the 2 wires. I do a jumper across between the 2 batteries, because you're going to feed them the same signal. But then I take that wire that they supply and I run it over to the black box, and I put it on the right-hand side of the disconnect relay. So in the black box, there's the silver starter solenoid, which is the isolation switch, the isolation relay, which is what connects and disconnects the chassis engine for charging. But then the disconnect switch, the coach on-off battery switch inside by the door, when you want to turn off all your power, that rectangular relay box on the right side of the black box, when you're looking at the stuff mounted on the panel, that relay is what turns off the power going inside to the 12-volt fuse box. The solar panels always connected directly to the batteries, but the inside fuse box and the converter are on the disconnectable side of that relay, which is the right side. The left side of the relay, the center connection between the center jumper between the isolation solenoid and the disconnect relay is where the batteries are connected. That's B plus all the time. But on the right side, on the other side of the disconnect relay, that big round half-inch nut terminal is what supplies power to the fuse box through a 50 amp self-resetting breaker, and also supplies power to the generator. So if you don't have your coach power on, the generator doesn't have power to start either. What I do is I tie into that. I take one of the connectors that they supply and shorten the red cable that they supply to the point where it's reaching the black box, and then put that large ring connection on that wire, slip it underneath the right side of that disconnect switch. And then what happens is that if you were going to store your rig where you're turning off the inside power, you're pushing the coach disconnect switch off, and all your lights are off and all your panels are off, your batteries are then also off in terms of the heater mode. The batteries themselves are still providing power. If they were needed, they would still get power from solar if it was available, but they're not going to turn on the heat mode. They're not going to waste their own power trying to keep themselves warm. If you're not using the rig anyway, you've got the switch off. So that's actually what I do normally for everybody, unless they ask for something else. I mean, what is it? Battleborn actually supplies in the kit for the hated models a switch that you're supposed to install inside on the panel somewhere. I never use that because nobody needs an extra switch they got to remember to turn on and off. It's like, oh, did I turn my batteries off? Just turn off the code switch the same as you always do, and the batteries will do the right thing. They won't use the heat to keep themselves so that they can charge, because you're not going to use the power out of them anyway. You're turning off the consumption of power by turning off the power to the fuse box.
What if I were to keep it plugged in all winter with the Battleborns?
At that point,
have the option.
Yeah, at that point, you have to keep the coach switch on anyway for the converter to be charging the batteries at all.
Yeah. Okay. Okay. Are you willing to help someone like me install?
That's actually one of the things that I do. So what's happened with me personally in the last 6 months is I used to be a software developer for 30 some odd years.
Yeah.
And I was just toying around with this whole helping people out with their RVs situation. And this people wanting lithium batteries installed has literally taken over to the point where I'm so busy doing this, I don't have time to do other software development projects. But it has given me some time to get some other projects done, such as the auto generator start, such as I'm now printing 3D panels to adapt the inverter control panel when you're doing the full Victron inverter, to adapt the Victron control panel to where the PCS was. So you take the PCF off the wall, put this plastic panel that's got the right holes and the right sizes. It's the same size as the PCS panel, except all black plastic, but it's got the hole for the new control, the new inverter control module to go into and screw in, as well as I've got a number of other adapters I've been working on to allow you to do things such as install the what is it called, the sea level tank sensors, which I love, which is the actual readout in percentage of tank volume, as opposed to just 3 steps. It's 100%. Nice system.
Yeah.
Works real well. Expensive to purchase. It's like $300 a start just to get the pieces of gear. And it's not an easy install because you got to touch all the tanks and run wires underneath and through the floor and blah blah blah. So it's a hassle to do. But I'm also doing the control panels for that. So yeah, that's kind of sort of what I'm doing. But I am fairly well booked up for the rest of the year. If somebody did want to see if I was available to do something, it would have to be somewhere where I'm already traveling towards anyway, and hopefully not a very long task. I mean, just swapping the two batteries is a couple of hours tops.
Right.
And the way to sign up for service for that and to see where I am or where I'm going to be is the stg.net website /service.html, which is you just go to stg.net and then hit the services tab. And there's a calendar there as well as instructions on how to get started.
New business for you.
Yeah, I kind of fell into this, doing the faucets, and I'm now doing the induction cooktop adapters, a whole bunch of stuff. The induction cooktop adapter, that's just a stainless steel ring that adapts the, you pull out your gas stove, you put this stainless steel ring in because it fits in the old hole, covers up where the original stove was, and then you drop in an electric induction burner into the hole that it has in it. So it's just a way of allowing you to go electric on your cooktop if you wanted to do that.
Yeah.
Which, if you've gone inverter, is a nice option. Or if you're already on an L, for example.
I'll look to set up an appointment with you because I like those options.
Yeah, and I also do a number of other things. Popular one right now is, especially on G, is a hot water bypass recirc valve. So it's actually a pretty simple mod on a G anyway. I'm usually doing it when I'm putting in the bathroom faucet, the MKBF, the thermostatic bathroom faucet, as it is on my website, which is on a G replacing the stupid little 2-knob and shower old school faucet with a really super nice, automatically adjusts the temperature to adjust the mix to try to keep the same temperature on the output, even as the hot temperature changes. It's a fancy faucet that has both a higher neck, so you can actually get underneath it easy and wash your hands or whatever, but also has the shower diverter, and you can dial up and down the flow rate very easily. So it's a really super nice faucet. I'm not the one that found it, but I did a video on how to put one in ages ago when I first put one in mine, and it's kind of a popular mod on the G's. And then people were saying, oh, they can't find the faucet anymore due to Diesel that was selling the original version no longer had the right part. They had changed model. And then the AliExpress ran out of stock as well. So I managed to track down a manufacturer, and I'm currently waiting on those parts to get, I already sold off what I had. I have a few in stock that are mostly spoken for people to install.
Yeah.
Mostly up at GNR.
Those are for the G.
That's for the G. Yeah. I mean, you can use the same faucet, say for a kitchen faucet. It was originally designed as a kitchen faucet with a little hand sprayer, but it's the intent of this is really to replace the G faucet.
Sure. Hey, thank you.
Yep.
And I watched your video about the Battle-Born batteries replacement. Well done.
Yeah, that's I make it look easy, as somebody commented. But that's because I have done so many of those over the last few years that I have worked all the kinks out of the process. I'm recommending start with I didn't always start with a negative. I'm like, well, I'll take positive off first. Well, it's so much easier to take the negative off first, because once you get both negatives lifted, well, now you can put the wrench on the positive, and even if you accidentally hit the metal of the frame of the van, you're not creating sparks because the ground's already lifted. So it's just, it's little things like that. I had already recorded the process of doing this change out once, actually a couple of times, and I kept finding ways to improve the process. It's like, no, I can't show that video. That's all wrong. I don't do it that way anymore. I've learned better. So yeah, I mean, by the time I'm putting the video out, I'm usually have done something enough times to have figured out what does or doesn't work. I don't know, why I came across the idea one day of using the tops off of the Battleborn packaging to drop the battery on. But man, is that so much easier. That has just made the whole process go so much more streamlined. And I'm not scraping up somebody's driveway as I'm pulling it out from underneath the van or the case. It's just every time I do this, I make a little better. I add a new tool, a new technique. Something. I just today I came up with a new little, already stowed in the back, but a new little template guide for when I'm putting a BMV in a 19 or later K that has actually I do the same thing with the G 19 or later. When they have the 1,000 watt inverter already, that little control panel, that little rectangular control panel, I Fastener drill that out to put the BMV there. And I came up with a little hole template that I can attach and clamp on around the bit of wood next to the ZAMP there, so that the hole where I want to put it through the wall matches up to the existing rectangular hole, because I got to drill out round with a Fastener, and that doesn't work. Nobody makes, that I know of, a step bit that is that 1.5 inches wide or whatever it is that the BMV needs. So
awesome.
Just makes the process go easier.
Sure.
Oh, another thing that I'm doing now, I have been having problems repeatedly with the Truma control panel. And what I mean to say is that the Truma's got a wonderful product, and it's a nice fancy control panel, but all of the other stuff from like Precision Electronics or whoever the Winnebago gets it from, all the other control panels and things that we have, they use the big Molex connectors, they use the 16 gauge wire, they're beefy and robust, and it's even when you're messing around in behind the wall trying to fish new wires through for a new control panel to go in, you're unlikely to damage something. Well, I've too many times damaged the Truma control panel. Usually what ends up happening is the tiny little power wires. They have to put the power from Winnebago through a 1 amp 1 amp fuse in order to drop the current limiting down to the point, because those wires are so thin. Otherwise they turn into if it accidentally got shorted, it would turn into igniter. But those wires are so thin, they're easy to break. And too many times I've either had problems with the wires breaking, or in one case I had the data connection pop off of the back of the Truma control panel. I soldered it back down. And it's like, I've had enough trouble with this. And then I had another instant where the panel stopped working entirely, and I couldn't even fix it. I had to get a new one. I was talking to Truma to try to figure out, can't they make some improvements to this? Turns out they have an improvement. They sell for an extra so many dollars a little plastic cover that goes on the back of the Truma control panel, holds everything in place and latches the cables down. It's fabulous, but Winnebago doesn't buy it and put it in because they don't figure on me, going around, or somebody else going around messing around in the back of the panel and accidentally putting too much tension. I mean, you have to think that there's these tiny little wires that the big, heavy, thick cabling that Winnebago uses is hanging on the tiny wires. So all that weight, as you're bouncing down the road, all the weight of the regular heavy Winnebago wires is bouncing on the tiny little wires that go into the control panel, and there's nothing to lock it down. This plastic panel does that. So a new feature that I have just started with, this installed today, is the first thing I do before doing anything behind the control panel wall is pull out the Truma and put the cover on the back side of it and lock the cables into the back cover. And that then secures and prevents, at least you know, I expect it to, and it's clear with the cover that it should, prevents any problems happening with the Truma control panel that I've had in the past. So it's one of those, I don't know why Winnebago doesn't install that, other than, you know, it's a hassle and they don't think it's necessary. Well, I do. So anybody that I'm messing around in their control panel wall from now on is getting one of those, just as a part of the deal. But I have a bunch of them in stock. I bought a bunch so that I can do that for anybody that's concerned about that.
Awesome.
So little things like that. As I do this, I get a little bit better at it.
I was afraid to do my first drilling, but I've done that now, so I'm okay.
Yeah, wait till you drill through the floor or the ceiling. That's fun, drilling through the metal. That scared me the first time I was doing that too, but I've gotten really good at it now, and I know right where to go through to you know how to like on a K, there's a particular spot next to the battery tray that I drill up for the 3 holes for the 1/0 cables that connect between the batteries below, batteries above, and the inverter.
Okay.
Because there's a battery positive, battery negative, and then chassis negative, which is separate from battery negative, because you have to put the BMV shunt between the two to measure all the batteries, measure the power in and out of all the batteries. The battery negatives are all isolated and go through the shunt. That's how the BMV 712 works. But yeah, drilling those holes, I've got that process down now where I know right where to put the holes, both on a K and a G. It's almost the same place, it's just a little different. And then on the K, what I do is take a chunk of wood and turn it up sideways underneath all of the plumbing that's coming across underneath the Truma there, between the Truma and the shower wall, to get it up off the floor so I can drill out the floor. Because the first thing I always do is start with a pilot drill from below up through the floor so that I've got the spot marked above. Then I come down with a 2-inch Forstner to router out the flooring down to the metal. And then I take a 1-inch metal cutting bit and I go through the floor, take out a chunk of the metal. And then I've got a PG-19 gland, which is a little clampy deal that holds on to the cable and it attaches through a hole. It's got a gasket and everything. And I put the gland, screw tight the gland in through that hole. Fits perfectly. And then the 1/0 cables go through that and get tightened down. And when I get done, I pour Dicor in around the base of all of the glands anyway to seal the whole thing down, so there's no leakage at all. And part of that technique is actually courtesy of Danny Hightower, was the one that put me onto the PG-19 glands. So not in all cases is this something where, you know, I came up with a better way of doing something. Sometimes somebody else came up with a better way of doing something, I totally stole it.
It's team effort.
Yeah. But at the end of the day, like I say, every time I do one of these, I get a little better at it.
Yeah.
And a little bit faster. I had my first Rodney tray, 4 batteries under a K, go 2 days. First time I ever got it installed done and completely done in only 2 days instead of the usual 3.
So if you get 4 batteries, do you need more solar?
Well, it's not a matter of you need more solar. It's a matter of you can never have too much solar because it's free power.
Yeah.
I say that knowing that, you know, some people, specifically Danny Hightower, have gone to the point of putting so much solar on their rig that they have more solar panels than they have roof. He's actually got slide outs for solar panels. So he's got, you know, 2 layers of solar. She's got solar panel wings that slide out from the side of his rig. And he actually occasionally brings in enough solar on a good hot sunny day to offset 100% of his air conditioner power.
Wow.
Now, he's not going to keep that up all day, but he's peaked out at enough solar to cover the air conditioner, which is itself amazing that he could just, you know, park out in the sun and keep the air conditioner running and not end up at the end of the day with the batteries completely drained in short order, because
Sure.
with 4 batteries, you're only going to run the air conditioner with the compressor running flat out, which it will do in really hot weather like this. You're only going to get 4 hours about out of the batteries before they're dead. And you got to do something to charge them. And the fastest way to charge them up is to start the generator, honestly. You know, that having the inverters and the batteries is nice because of how many times I do not have to start the generator.
Right.
But occasionally when there's enough power usage, when it's really hot, when the air conditioner is really cranking and I'm not plugged in, you know, my solar and my driving isn't enough to offset my air conditioner use, and it'll end up kicking in. You know, right now I'm actually plugged in, set to a current limit of 10 because I'm borrowing a garage circuit, and I'm still at 100%, even though at the moment, I don't know if you can see this. You can't see this. I'd have to share the screen. Let me see if I can do that.
I'm still trying to understand all this electric stuff. I mean, I've never had anything
There we go.
to do with it. I'll get there, but it'll take time.
Yeah, it's not the easiest thing in the world, to be sure. Let me see if I can get this to share now. Hold on. Oop, where'd you go? There we are. Share screen. That one. Oh, I have to hit share again. There we are. So this is my live system, what I have running here. Now, you have to also understand that I am running a slightly more advanced version of Victron system. So there's your basic BMV 712 that monitors your power in or out of your batteries. That tells you what your percentage battery is very accurately. Then there's your Victron 3000 inverter, and you get some settings on that. And if you've put in the Victron MPPT solar controller, you know, that also has, and each one of these has its own Bluetooth interface that you can pull up on a phone app. But there is a separate master control module, if you will. In this case, I'm using the Victron Serbo, although there is also a single stick on the wall panel unit called a color control that is basically the same thing. I've got the fancier, does more Serbo unit, which has a separate touchscreen panel, which is easy to install. And I got a video online about all this as well, showing off what the Victron Serbo does. But you can see here, I've got shore power coming in. I've got AC power going out. So AC in, AC out across the top. Inverters here, this blue box in the middle on the top row. And then the bottom row is my 12 volt stuff. I've got my batteries. I've got whatever power that's going into the other 12 volt DC lights and other 12 volt things that are using power are listed under DC power there. And then the solar solar controller, which of course I'm not getting any solar right now because there's no sun. But what's interesting is, and you can see right now I'm charging the batteries. I've got a decreasing amount of shore wattage coming in, currently 500 watts, and it's going down slowly as the battery charges up. And it's charging the battery. You know, I've got 400 watts coming in, 90 some watts going into the battery, 70 some, 80 some watts going into other lights and stuff that are on. And there's still 300 watts of other load. The fan on my air conditioner is still running. But when the compressor kicks in, my AC loads, the green box, shows more wattage that I'm putting out to run the air conditioner than what I've got coming in from shore. And there's a reason for that, and I'll show you what I mean by this. If I go into the menu and I go into the inverter, come on, click it already. There we go. I have input current limit. This is a feature of the Victron 3000 inverter that I can specify down to about 8 amps or up to 30 or anywhere in between. How much shore power in current it's allowed to consume. So for example, if I'm at a 30 amp campground, I'm going to set this to 30 and I'm going to use the whole 30 coming in without the inverter trying to do any assisting. But if, for example, as I am right now, I'm plugged into what's probably a 15 amp garage circuit, but there's probably something else on the circuit too. So rather than take a chance of pop the breaker in the house where I'm borrowing power from, I've got my current limit set at 10. Now I can turn this up and down, but I'm going to leave it at 10. And I always set it to 22 when I'm running a generator because it's about what the generator can reliably put out. But what this does is it prevents the inverter from sucking in more power and potentially popping the breaker. Oop, wrong button that first thing. So if I go back to my other screen here. So right now I'm evening out. I've got my battery's gotten charged up again. So I'm now at 0 amps. I've got exactly no power going in or out of the batteries. And this is a normal state for the battle boards. Once they aren't being used, once there's not any power being used from them, and they don't want to take any more power because they're charged up enough. They know they're charged and you're not borrowing power from them. They shut down. They go to zero current in and out, which extends the lifetime of the battery. It's a nice feature. But what's happening here though is that this little bit of difference, the difference between 384 short coming in and 300 watts going out, which is fans and probably also my refrigerator. That difference is coming down here and running the 60 watts of DC power. So my lights and everything are now running off of shore power rather than taking any power out of the battery, even though they're connected directly across the battery. Same as everything else, the inverter included. But as soon as the air conditioner compressor kicks in, because I've got that current limit set at 10, and what that really means is that, well, really only do like 9-ish. You know, don't if you come up towards 9, stop there. Don't take any more power than that. Amps, which would be under 1,000 watts, I think. That's not right. Be 1,200. 10 amps would be 1,200 watts, but 9 amps would be well, 100 some less than that. So it'd be a little bit over 1,000 watts is the most that the inverter would allow, and it won't usually get up all that close. It'll leave an amp or two. It'll run with an amp or two less than what your current limit is set to. So what happens is, and of course I'd have to either wait for the air conditioner to kick in or go over and turn it down so it would crank up again the compressor. Well, what'll happen is the AC loads then will go above the shore power. And what's happening there is that, and because of the current limit, the inverter refuses to take more shore power, but it still generates enough power from the battery, using the battery power, to keep whatever you're running going. So for example, 10 amps of shore power is 1015 is really enough to run the air conditioner. But let's say that my air conditioner was running, it was running mostly on shore power, but then we'll go to cook something in the microwave. Well, when the microwave kicks in, you're definitely going to be above your 10 or 15 amps at that point. And it's going to take the power from the battery to generate the extra it needs for the in-house 120 volts. Oh, no, the air conditioner just kicked in. So now I'm running 1,300 watts of loads through the inverter between the 1,000 coming in and the 1,300 going out. And the other 500 watts is coming out of it dropped down to 900 coming in. The other 500 watts is coming out of the battery.
But the shore power will never go above 900 or 1,000.
Yeah. So it won't go much above 1,000 because I've got the current limit set to 10. Now I could turn that up and it would change right away.
Sure.
I can play with that number to find a point where I'm able to run the air conditioner completely from shore power without it taking any battery power, so that I'm not draining the battery. Now in this case, every time the compressor runs, it's going to take some battery power to supplement, and then it'll charge it back up again, which is wear on the battery. It's a small amount of wear on the battery. It's not a big deal. But I'd rather do that in this circumstance than take the chance of popping the breaker.
Sure.
So I'm perfectly happy with that. And I'm happy with having the ability with this Victron system to do this. Now you can do the same thing without the Venus, without the Serbo or the digital color control. The huge advantage of the digital control panel, or the digital color control rather, or the Serbo is this graphical display that shows you all of your power in and out at the same time. It really is a lot more clear what's going on.
Exactly.
And so there are people, I have installed a number of these systems. There are people that would prefer to do this style of the Serbo, and there's a touch panel up on my wall that has the same screen. Right now I'm pulling this screen remotely in across my wireless network. Mm-hmm. The Serbo exists on the wireless network. It also emails me when it has an alarm. Okay. So for example, if the BMV goes below the 10% that I've set as the alarm level for the batteries, it'll actually send me an email and say, hey, this has got an alarm setting. Or if the inverter overloads, or if the voltage goes too low. There's a number of alarm systems. It also gives me the auto generator start mechanism. You can also do that with the BMV, but I'll show you what I mean. Let's see here. I'm gonna go down to generator. Here we go. Come on. So I have, here we go. I have I have a relay output the same way the BMV does it. I have a relay output that goes to my auto generator start circuit that actually pushes virtually the buttons using relays again on the signals to the Cummins own generator to start it when I want to automatically. And I can set the conditions. Come on, click the conditions. There it is. I can set the conditions based on a number of different criteria. I can set it on SOC because there's so much power coming out of the battery, because there's so much voltage gone down, or so a certain load, wattage on the AC side. The most common one is battery SOC, and I have mine set at 20%, it starts the generator, and at 80%, it stops the generator. And unlike the BMV 712, these fancy graphical units, the color control panel and the Serbo with the touchscreen, have the ability to set generator hours. You can set quiet hours for your generator, and then it uses the alternate values instead.
Wow.
So that's what that does. And there's all kinds of different criteria. I can turn on start the generator if the inverter's overloading or high temp or whatever, or just on a periodic basis. So that's a nice feature. Another nice feature that I haven't wired in yet is that this thing can talk to the sea level. And let's see if I can get it to show up here. I don't have a real hookup yet, but you can get it to display your tank levels in the touch screen. So whereas the one place is the old one place that you could do everything. If you go, full-blown Victron system and get the special sea level control panel that has the extra CAN bus communications mechanism, and there's all kinds of stuff I'm still figuring out. You could then get to the point where even your tank levels, all of them, were displayed on your touch panel. So you have one touch panel to rule everything. Yeah. I don't have it yet controlling the water pump. I might do that someday. But it's a pretty powerful system, and there's several pages of things. Here's where I can actually just push a button and start the generator right from the screen. And because I've got mine connected up on the internet through my cell modems, I've got the cellular Wi-Fi modem in the van. Because I've got that, I can actually run this remotely. I can be away from the van, get the email saying that batteries are low, and go in here and push the button and start the generator, assuming I had the auto generator off to begin with.
Sure.
Because otherwise it would just do it on its own.
Wow.
So pretty fancy, pretty complicated,
Yeah.
but very powerful also in terms of what you can do with the Victron equipment. I really do like the Victron equipment. There's a few quirks about it, but one of the other nice things is it's open source. You can go in and play with it. The some of the numbers here on the battery are ones that I've actually added. The time remaining on, the time remaining on charging or discharging the battery is not part of the default display panel. I've actually added code to put that in because I wanted to see that.
Ah.
Scott, I have a question.
Yeah.
Is there any standalone generator start other than with Victron that you can easily bolt on to do the essentially similar to what Victron's doing?
Yeah. There's and I forgot. It was a write up on the Travada mods page. There's a I believe it's one of the inverter outfits that has a little control panel. It's really just hides somewhere. It's not really a wall control panel, but it allows you to set up generator start signaling using battery voltage. And that's a common thing. And even Cummins themselves sells a generator control panel that lets you automatically start the generator based on a number of different signals, including battery voltage.
Right. Yeah, I was just thinking, you know, we have a pet, we have a dog, and, you know, sometimes we leave it and try to go into an event or you know, something we want to see, but, you know, we only have 2 lithium batteries, and I'm thinking that maybe sometimes that wouldn't be enough. So I'm wondering about a couple of things. First, can I get this auto start for the generator? Number 2, how many people am I going to disturb if the generator automatically comes out in the middle of the parking lot?
And that depends on where exactly you are.
Right.
A lot of times I'll park on purpose somewhere where I know that in case the generator comes on automatically, you know, it's not going to be a bother to people. You know, I'm parking out by a main roadway where there's all kinds of road traffic noise anyway, not next to somebody's house or hotels rooms or such.
Right.
So
and I've done the same thing, you know,
so that's just something to be concerned about. Even with only 2 batteries though, you could install the BMV 712 and then use that to trigger. The nice thing about the BMV 712 is that it gives you a really accurate, you know, tracking of the voltage. I mean, of this.
The Victron system for, you know, a shunt to measure the. Maybe I'm a little confused here. So
no, that's exactly what it is. Let me pull up.
Okay. I bought a different shunt. It doesn't have Bluetooth or any. See, so.
Yeah, the huge advantage of the BMV 712 is it has that really accurate tracking, and it will handle up to 500 amps, which is more than the Victron inverter will pull.
Right.
Oh, they don't even have the right picture here. That's not right.
Right.
No, I don't see it.
I went with the Chinese version, the one that's like $35 or something like that, but doesn't have to get accurate shunt measurements. So
the nice thing about this is it has the relay contacts on it.
Yeah.
Which you can program to close based on SOC, and then this gets wired to the auto generator start circuit that I have, which is not quite for sale yet, but it's about to be.
Yeah.
I've worked all the kinks out of that process. I just haven't built them up yet to sell them.
Right.
And then, so these relay goes into the auto generator start. The auto generator start is wired across the back of the one place. So it borrows power from one place but then it's attached to the start-stop signals going to the generator as well, so that it can trigger start and stop, but you still then on the one place have the ability to, oh, I didn't want the generator running, and hit stop, and then stop.
So price-wise, I think the monitor, the shunt is like a couple $100. What's the and what's the other device it has to hook to? What is that?
Well, the BMV 712 comes with the shunt and everything. It's a couple $100 from that.
Right. Okay. And then the other end of it, to start the generator, there's some device it has to hook into, or?
Yeah, and I'll be selling that for 100.
Oh, okay. Well, that's not that bad.
Yeah, and it comes with its own instruction set of how there's an instruction online right now, but it's on the previous version. I made some significant improvements to simplify the installation, and I just make it a nicer package in a plastic, 3D printed box.
Okay.
And so that's that'll be available soonish.
Okay.
Sometime in the next month, I'll probably get around to putting some up online on Amazon.
Okay. Perfect. Okay. Thank you.
You're very welcome. Any other questions? All right. Well, if we don't have any other questions or anybody wanting to show off their fun new mod, I may just close it out here in a minute because I'm tired.
Okay, I want to thank you because my head is about to explode from everything I heard. So,
well, and I've got it recorded, and I'll post the recording later.
Perfect.
This is an awesome thing. Thank you.
Yeah, you're welcome. I'm enjoying doing this, and I know there's been enough interest. There's always people asking me, like, how do you do this and how do you do that? It'll be easier if I, push some of this information out on a regular basis, because I'm constantly coming up with new things. I only just got into the sea level tank sensors, and that's another one of those things where, Danny Hightower did it first, so it's all his fault. And now I'm trying to do. I'm stealing everybody else's good ideas and picking and choosing from the ones I want to do, and then turn around and say, okay, look, I've documented how to do this, and this is how you do it. I've got a way that I came up with of installing the LIBAM where the boost switch still works as intended, which, I had put in probably 3 or 4 of those before I had come across that, and I'm slapping myself in the forehead now. It's like, why didn't I think of that sooner? It makes it so much easier than have to run all those extra wires for the extra switch. So it's and it reuses the diode that was already there for the back EMF on the solenoid anyway. So
any thought on unlimited shower yet?
Unlimited shower? No, I do a really slow trickle until I need to rinse off.
But you've seen these recyclable filtered showers, right?
Oh yeah, I've thought about that. I've thought about that, and I thought about the one where you do a significant filtering out of the gray tank and use that water to run the toilet.
Oh, that's good. Wow.
So that your shower water gets reused.
Yeah.
And that it both extends your gray tank life and preserves your fresh water.
Wow.
Catch-22 is I still want to expand my black tank. I don't have a big enough black tank to survive. My black tank is always first thing to fill.
Yeah.
We've got the process down fairly well, unless we're like showering like crazy. That the I don't run out of fresh water. I don't fill the gray tank usually first. Almost always the black tank gets filled first, which is another reason why I'm going with the sea level, because my sensors don't work. My old sensors don't work. Actually, the problem isn't the sensor. I got one of the little display panel units that are compatible with the sensors that Winnebago puts in. And I clipped it onto the wire. I wired it up with the same connector. And I clipped it onto the plug that comes up from the sensors on the black tank and tested it out, and it reads perfectly. So what I figure has happened, and this is fairly commonplace because I had it happen in one of the light circuits, is that one of the long runs of cables through the van where they have those Molex connectors that connect, one of them has become resistive. And so it'll show 1/3, it'll show 2/3. Sometimes it never goes to full because there's not enough current getting through that bad connection.
Yeah.
Is what I
think
figured would happen.
something like that in my propane sensor, you know, so
yeah.
it's never right.
Yeah, and that's the nice thing about the sea level is that the sea level display also gives you propane readout. You just wire it across the propane signal wire. And apparently what it does, and I just read up on this and Danny was telling me, I haven't had it long enough to know. I actually haven't recharged my propane since I put it in yet. It's been sitting at 19 forever. But it apparently watches the range that it goes to and adjusts 0 and 100% based on that. So it ends up becoming over time more accurate.
So it's smart.
It's smart. Yeah, the sea level is an extremely smart all digital system. And it's got sensor pads you stick on the tank that do a capacitive sense. It's not all that dissimilar rather technology to what Winnebago installs, but instead of just 3 sensor pads that either they sense something there or not, and they can't tell what's between, how far you are between the 2 pads. What this thing does is it has a very wide, very long pad and a whole series of them. So it's got like 8 divisions, but then it can sense how much of the pad is covered up. So it can calculate based on the feedback it's getting from the pads, where the level of the tank actually is between pads. So it's
Ain't technology.
Oh, it is. It really is. And like I say, I mean, it's clear why Winnebago doesn't install it. You know, it's a 3-4x cost difference. You know, it's quite a bit more costly for the sea level.
Yeah.
But the difference in resolution is so amazing. It's not funny. I can latch in the freshwater tank so that it keeps displaying it. And I go outside and I turn on the pump. I turn on the water to fill the tank, and I watch it approach 100%. And when it gets like within 5% of 100%, I will run over and turn off the water. And right about the time the water shuts off, I get a little bit of water squirt out the holes, and that's it.
Nice.
It's dead on.
Yeah.
It really is accurate.
That's good.
Yeah, I like the sea level. All right. Well, GNR is coming up soon. Hope to see you all there, or whoever's going.
Yeah, I'll be going.
Well, we'll see you there. Hopefully,
Okay.
we'll have something like this at GNR. Is GNR covering a Monday?
I have no idea. You have to ask them.
No, I mean, when does GNR start?
No, when GNR starts.
22nd.
I don't know.
25th. Oh, no, 26th is Monday, I think.
So it starts on Monday?
Sunday, 25th.
So it starts Sunday. Or is that pre-GNR? Well, it doesn't matter. If we happen to be on a Monday, we'll be doing this from GNR, and if not, maybe we'll do an impromptu thing at the TED to GNR one of the days anyway. All right.
Sounds good. See you there.
Yep. See y'all.
Thank you.
Night. How do I turn this thing off? Oh, there we go. Stop share. And